Please help yourself with chocolate, actually.
This is right, or are you driving us?
No, actually, I thought that, yeah.
Oh, funny.
It's
not allowed to accept this.
Not working.
No,
You can take one of my brownies.
That's the difference.
Actually, because in mornings I need to eat something before I start, so I thought that that should be the case with the recipe. All right, so just help yourself.
Welcome to the Master Defense of Erfan. So you wrote his thesis on challenges of blockchain design, and well, I don't want to talk further about that, but he's going to present that in detail. And actually, yesterday Erfan asked me about whether it's okay to bring sweets here because that's some kind of traditional thing to do in Iran for such an event, and so I said that probably we will not
actually, sometimes you don't have to avoid or lunch actually.
Entertain your professors, or feed them, or what is the idea?
If they're not interested in the subject, they can still have one.
Ah, that's the concept. Okay.
Yeah. Please go ahead. The floor is yours.
Find my mice.
It's interesting. I should keep to the room.
Okay. So, hi everyone, I'm Irfan. My thesis is about challenges of blockchain design. Due to the limited amount of time that I have, I will not cover everything, so I will only focus on chapter 4 and 5, but up to 70% of what I have in chapter 4 and 5. The agenda is why this research is important, so why you should read this. What does it mean to be trustless in the context of public and private blockchain? What does it mean to be decentralized? We try to formalize the language that is being used in this field, and the properties that we think a suitable private blockchain needs to have to be able to be adopted at enterprise level. And at the end, we would share with you an approach that we have for technology selection. Primarily, I try to answer these 6 questions. Basically, what does it mean to be trustless and how far we can be trustless? The same thing goes with decentralization. What are the necessary properties that we think a private blockchain needs to have? What kind of use cases can be implemented by blockchain? And an approach for technology selection among different blockchain technologies. The motivation for this research, one of them is Gartner's hype cycle, that blockchain is still at the peak of inflated expectation. It is coming down, but still it is something very at height. The other thing is that I was involved in a blockchain project, and I received this email not from a layman, but from an IT engineer who says that some influential people think it makes sense to implement these use cases first in the data lake, basically a relational DB with talent used for any required business logic, and they believe and suggest it would be easy to then port it to any DLT. DLT is Decentralized Ledger Technology, another name for private blockchains that some technologies like Corda or Fabric, in order to differentiate themselves, call it. They're thinking that DLT is just a database anyway. So we understood there are a lot of misunderstandings around blockchain. One of them is that blockchain is just a cryptocurrency. In some event, I saw people saving hash value inside a blockchain, inside a database, and they think that now they have a blockchain. And also, blockchain, some people think that it is a distributed database, just like data lake. And the other motivation is that there are a lot of consortiums around blockchain. So there are a lot of different attempts to make new use cases of it and also to understand it. One of them is Interchain, which is a blockchain for energy. One of them is EWF, which is Energy Web Foundation in North America. They have made a new grid system, and also they have a blockchain called Tobalova. R3 Corda, which has JP Morgan as a member to Deutsche Bank. JP Morgan this year, they left because of some reasons. Hyperledger Foundation, in which you have SAP, Microsoft, Oracle. So you see old competitors, they are cooperating with each other to both develop the technology and to understand new use cases for it. And of course, we have Ethereum Enterprise Alliance. I suppose that everyone here is very familiar with blockchain because I only focus on chapter 4, but in order to reach the same understanding, let's just cover a couple of concepts. One is, what is a blockchain? A ledger or repository containing all transactions conducted within a business network, shared among all members of the network by peer-to-peer replication, secures based on cryptography and hash functions. There are a couple of keywords when you deal with blockchains. One is distributed, decentralized. I will clarify how they're different. Secure in the sense that the underlying cryptography, like for example SHA-3, it has not been broken. Trustless, I will define that. Shared ledger, consensus mechanism, and a chain of block. From my perspective, blockchain is nothing more than just a data structure. So in which you have hash functions, each referring to the previous block. So if the content is modified, the new hash value does not match with the previous one. And also you have a Merkle tree, another data structure based on hash functions, that you have transactions that are being hashed, they're appended together, being hashed, appended together until you reach the root of the tree, and the Merkle root is being saved inside the block. So if one of these transactions are modified, the root doesn't match. In this way you have something immutable. So one of the things is that there are a lot of claims out there, like for example, Fabric says that we are trustless, Corda says we are trustless, so we try to understand how trustless they are. So first of all, we need to define what does it mean to be trustless. So trustlessness, in this, we understood, okay, at least in the world of cryptocurrency, it means doing business with those you do not know, with no intermediary. Because you do not know people, people have incentive to behave maliciously. So the system can be, at some point, be faulty. So there are two different faults, fail-stop failures, and you have Byzantine fault failures. In fail-stop, the node just crashes, it doesn't work, but in Byzantine behavior, it can also just just do not respond, or also it can send false values or reach consensus on false values. And it is decentralized in the sense that there is no central authority, no single point of failure, no single point of administration. I will open this in a few slides later. And there is a shared ledger. So all data is shared among all members see the same version of truth. So basically in this case it is just a machine state replication that I will open it a bit later. So this is from Ethereum's white paper. Vitalik suggests that we can consider blockchain just as an apply function, so which takes the state of the system and transactions and apply the transaction on the state and reaches a new state. So in this case, he says that we can consider Bitcoin, for example, in these 3 lines of, we can explain what Bitcoin is. So for each transaction, for each input in a transaction, if the reference UTXO is not in S, return an error. If you do not know what UTXO is, just ask me later, but it is unspent transaction output. There are basically 2 different types of blockchains. They're either account-based or based on UTXO. The account-based are like Ethereum, are like Fabric, that you have an account, a unique ID, and you have a couple of assets associated to that account. And then you have UTXO, unspent transaction output, that you do not have any accounts, you just need to consume the UTXOs and create new UTXOs that have not been consumed yet, therefore you can consume them. So the first one, that means if I'm trying to spend some coin that does not exist, return an error. If the provider signature does not match the owner of the UTXO, return an error. That means if you try to spend someone else's coin, return an error. If the sum of denominations of all input UTXOs is less than the output UTXOs, return an error. That means in transferring money, no money is being destroyed. If not all of these checks are fine, just return the new state of the system. Just remember the email I showed you. So this is an example of a data lake. This is Cassandra, that you have a couple of different data centers, each have their own nodes, but the point is that why it's not a blockchain. So basically, in this example, Cassandra, you have a partition key, which is part of the primary key. So when one of these nodes gets some data, based on the partition key, they decide whether they need to save it or not. So there is a kind of sharding here that is being used. And you have a replication factor. For instance, you have, with replication factor of 3, you save data in 3 of the nodes in this data center. In Cassandra, you can also set it in order to save that data with another replication factor in another neighboring data center. So 2 differences here, 3 differences at least. One is the replication factor is much lower than blockchain, because in blockchain every node sees the same thing except for IPFS and Corda, they have a different architecture, but that is the idea. And the other thing is that there is no sharding in databases. There were discussions in Bitcoin, it never happened, and there were discussions in Ethereum that are not realized yet. And then the other thing is that this system is distributed, but it is being administered centrally. Therefore, it is distributed, but it is not decentralized. So that's one point. So about decentralization, there is no silver bullet definition of decentralization, but what I accepted in my thesis is that in order to have a decentralized system, you need to have a peer-to-peer network, nodes behave independently, they do not have any privilege over one another, and there is no information asymmetry. I took it from finance, this concept of information asymmetry, because I later on understood that if you have information that others do not have, you will gain privilege, and at some point you need to trust the system, like what is happening with oracles in databases. And then system is robust against failures, as I explained. Nodes interact with one another by gossip protocol, and there is no central administration. I consider such a system decentralized.
What is the gossip protocol?
I mean, so one node when finds something or finds a block, it would, for example, with gossiping, it would send it to everyone else.
Okay.
So there is no point-to-point communication, but there is gossiping.
Mm-hmm.
So I consider these as the prerequisites of a decentralized system. Now we talk about trustlessness, but what does it mean to be trustless in the enterprise context, or can you be trustless? So one example is Ferrari Lorenzo, for instance. If you want to buy one of these, there are only 400 of them, you need to apply to have it. So you need to send your CV and your request, and the factory decides if they sell it to you or not. So you do not choose them, they will choose you. Another simple example is steel. So, you know, recently United States and Turkey, they've got into some problems, so United States increases the tariff rate. So despite the fact that steel is the same, or has passed the same qualification controls, but the tariff rate on the steel of South Korea is not the same as the tariff rate of Turkey. Therefore, you need to know who you are dealing with, otherwise you may apply the wrong tariff. Or the other thing is you may buy, if you do not know what you are buying from, who you are buying from, you may end up buying stuff from terrorists. So ISIS, a few years ago, they gained control over the oil facilities, and Turkey was the only country that was buying oil from them. So if you do not conduct knowing your customer KYC actually protocols, you may sell to wrong people, you may hurt your brand, you may apply wrong regulations by applying wrong tariffs, or you may buy something that you were not supposed to buy, or you may sell something to someone that you were not supposed to sell, like airplanes, and you may support terrorism, and a very normal case is money laundering. So how far a system can be trustless at enterprise level? Systems cannot be completely trustless. So you already know who you are doing business with. From two perspectives, systems cannot be trustless. One is that you as a business, you do not want to do business with someone you do not know, because that will put you into a lot of troubles and expose you to a lot of risks. The other thing is that the technologies, private blockchain technologies, are not completely trustless. All of them are based on some kind of consortium. So you need to develop a consortium of your partners, and within that consortium, everything is clear. You define the policies, you know the roles, who would become the doorman, who would become the certificate authority, who would become the orderer that, for example, that checks the policy, etc. And that's why private blockchains are mostly not Byzantine fault tolerant, because Byzantine fault tolerant consensus algorithms, they are difficult, they are less efficient actually in comparison with the ones that are not Byzantine fault tolerant. As an example, Hyperledger Fabric uses selective endorsement, which is not Byzantine fault tolerant. Or Quorum, JP Morgan's blockchain, is using Raft, which is again not Byzantine fault tolerant. However, in future they are thinking of, Fabric is thinking of being again Byzantine fault tolerant. And how decentralized blockchain technologies can be, the ones that are being used at enterprises, they are not as decentralized as the ones that are in cryptocurrency, because some nodes are more privileged, some nodes have access to data that others do not have, and the administration of the system at some point is more centralized. For instance, in Fabric, there are orderers which see everything. They make the blocks, they check the policies, they check the signatures. There are certificate authorities which publish, which issue certificates, public and private keys. There are membership service providers which are the gateway to channels. If they do not allow you, you will not be able to join a channel. The same concepts are in Quota in a different way, like you have a Quota doorman in order to join the network. You have notaries. You can later on ask me about notaries, but in my thesis I have discussed that if you have a notary or a cluster of notaries that do both uniqueness verification to prevent double spending and validation verification to check the content of the blocks, they have much more information than other peers, and if a cluster of notaries decide to behave maliciously for some time, they would not be seen, or they would not be, they can hurt the system for a while before they would be exposed. And for example, in Corda, you do not have gossip project, where you have point-to-point communication. Therefore, you need to have also a network service map. In chapter 2, I've explained this in detail when I went to Fabric. You don't need to know what is happening, but the point is that you have an orderer, which is seeing the content inside the channels, while you have a peer who doesn't even know a channel C2 exists, which is a great thing in case of confidentiality, but you can see that there is information asymmetry, and this information asymmetry gives more power to the orderer, or for example, to the certificate authorities. So the other thing that we worked on in chapter 4 were properties that a private blockchain needs to have. I suggested 8 properties. We do not have time to go through all of them in order to see the line of argumentation. I just chose 3 of them to say why I think these 3 are important. One is modularity. By modularity, we mean how we can replace one technology with one another. For instance, in Hyperledger Fabric, the default database is, I guess you cannot see, right? No? The default database in Fabric is CouchDB, so which you can change with LevelDB, and also you can change it with MongoDB. So the important point is, think in the context of enterprise. It's not about the startups that you can choose whatever technology you want to work with. At enterprise level, you have cloud management committee, you have security departments, so they need to, you have a standard set of software that you are allowed to work with. Therefore, and the other thing is that at enterprise, you may have experts of MongoDB, you may have experts of SQL Server. So if the technology allows you to change, if it is modular and allows you to change the underlying technologies, it would allow you to use the expertise and the know-how that already exists in the enterprise, and would facilitate adopting it. Also, the other thing that is important is changing the consensus mechanism. For instance, if you are in more open environments, if you are in more public use cases, you need to be Byzantine fault tolerant, while if you are in a more private environment, you do not need to be Byzantine fault tolerant. Therefore, in Fabric, they are planning to use in future SBFT, Simplified Byzantine Fault Tolerant, parallel to selective endorsement. In Corda, it is already there. In Corda, you can use either Raft or ABFT, Asynchronous Byzantine Fault Tolerant algorithm. Interoperability is another point. So while I was doing research, I understood that some part of the community, they were claiming that it is difficult to read data from different ERPs. So for example, if I use SAP and you use Sage, at the border of our enterprises, that would be difficult that our 2 systems communicate with one another. And if we use blockchain, that would facilitate this stuff, which is not necessarily true, because if I use my DApp, my decentralized application on Ethereum, and you use yours on Fabric, what would happen is that again we would have difficulties communicating with one another. Therefore, it is important that different technologies they follow the same protocols and the same standards. There are already attempts in order to make these technologies interoperable. One of them is Hyperledger Bureau, which is one of the projects of Hyperledger Foundation, which allows executing of Ethereum smart contracts on Fabric nodes. And you have also Hyperledger Iroha, which allows developing mobile applications for iOS and Android on top of Hyperledger Fabric. The other thing is confidentiality. So basically, I think there are 2 main barriers of adopting private blockchains at enterprise. One is confidentiality and the other one is throughput. By confidentiality, I mean, there are a couple of regulations. For example, you cannot save some kind of data outside the European Union. So you may have a partner in Russia, but your data should not be replicated on their servers. Therefore, confidentiality is very important. You can go ahead and build some application on top of Ethereum, but then everyone will see who you are working and how much value you are transferring, something that you are not allowed to do. And the other thing is that there are regulations to protect your customers, so your customer data should not be revealed. And you as a business, you are not willing to reveal information about your suppliers, because working with the specific suppliers may give you competitive advantage that you are not willing to share with others. And also the price of products or the conditions of working with you, etc., should not be revealed easily. So these are the necessary properties that at the end I come up with: modularity, interoperability, confidentiality, scalability, high throughput. By the way, what I meant throughout the thesis by scalability is a bit different with what you see in a couple of texts. So by scalability, at some point, some people mean that being able to cope with higher volumes of transactions. That's not what I mean by scalability. That's why I put high throughput differently. By scalability, I mean how easily nodes can join the network, the business network, or the blockchain, and how easily they can be dropped without causing any problems or reducing the efficiency. Independent functionality of deployment environment, which is about blockchain as a service. You can ask me after this. At the end, I will explain to you if you want. Zero knowledge proof, like the algorithm like the protocol that are being used by Monero or Zcash. Just ask me later if you want to. And support of a fully object-oriented language. The other thing that is important is deterministic execution of smart contracts, because as I said, blockchain is a machine state replication system. If I execute a smart contract and I reach a different state than Jens, then we will never get into consensus. Therefore, it is very important to be able to execute it in a deterministic manner. I come up with a couple of architectures. One of them is this one, a sandbox, which is inspired by Corda, because in Corda you have a JVM sandbox which doesn't allow to execute any libraries or to import any libraries that bring in any kind of randomness. So that's one idea. The other idea that I come up with is that let's have a trusted execution environment with the smart contracts. Just fetch the blockchain state, and in this trusted execution environment, we prevent importing of any of the libraries that bring randomness. We execute, we apply the transaction on the state, and with another smart contract, we just push the changes into the blockchain. About the use cases of current blockchain technologies, so there was a startup pitch, and this guy was talking about they're working on a recommender system in order to recommend videos to their users, and he was claiming that because now we have blockchain, we know exactly what users see, and at the end we can suggest them something what they really want to see. So basically that's a bad use case of blockchain, because he was using blockchain, they were planning of using blockchain instead of a database, which is not even a good database. And having recommendation algorithms like collaborative-based filtering, content-based filtering has nothing to do with what database you are using. So that was completely irrelevant. Or it was another conference and someone suggested blockchain is revolutionizing ad tech, advertisement technology. And they were claiming that because now you are saving transactions of users inside the blockchain, you can see if someone has clicked on an ad, and if when they are redirected to your website, if they have bought the stuff or not. But you already have had this for a couple of years with Google technologies. So again, it is irrelevant. You can easily monitor the traffic of your website. And blockchain, also there was an event, I was talking with a company from Singapore, and it was their ICO, and they were talking about using blockchain in a strategic game, in games. So imagine that you have an army going to siege a village, and because it is moving, the oracles cannot reach agreement on where it is. So that is also true if you use it for navigation, for tracing cars. So that is also not a good use case of blockchain. And here you can see an example. The guy says, make it turn left. Yeah, but we need to wait for the command to be mined. So there are a couple of things that blockchain is being used which is not suitable. But a couple of suitable use cases, mainly in finance and supply chain. Walmart and Alibaba are using it for tracing goods. Myers has done a POC with IBM on Hyperledger Fabric in order to trace their cargoes and freights from Netherlands to Africa. They also integrated the information of IoTs and RFIDs in order to always check the condition of the containers. And it is an enabler for sharing economy. It has not been used yet with Ripple and Corda, but hopefully this year it will be done, especially with Ripple, to do cross-border payments instead of SWIFT. And so the idea is that blockchain is suitable to be used at endpoints. So for example, at the port to check the condition of the goods, for example, inside the container, or for example, you put the RFID information inside the blockchain, so if it has changed the color, you know that that information is already put inside the blockchain. That's something that is a good use case, but in one of the papers I read, if the information is saved inside the blockchain, but if, for example, someone makes a hole inside the container and take out all the teddy bears and put cocaine there, still the information from the blockchain perspective is true, but it is, I just want to say that what you can expect. an approach for technology selection. There are already works being done. You don't need to read this, so I just wanted to say that works has been done about deciding when to use blockchain instead of a database, or when we can think of using blockchain. In this work, I tried to take one step further and propose something. I said, what I suggest is that let's look at these 7 properties: number of participants, needed transparency, needed storage, auditability, privacy, confidentiality, and scalability. And privacy and confidentiality are different in the sense that in privacy you are the owner of your data, no one has the right to look into your data, to tamper with your data, while confidentiality is more a legal term in the sense that so if you have some data that no one should look into except for the regulator, that is something confidential. Or if the data can be viewed only by explicit consensus of the user, that is something confidential. That's what I mean by confidentiality. And so what I suggest is that when you do requirement analysis, also look into these 7 areas and see if your use case, where your use case is situated. So this is low, this is high. And based on that, you have also a couple of standard technologies that you are allowed to use at enterprise. So you come up with a couple of technologies like Quorum, like Hashgraph, like IOTA, whatever. Then see where each of those technologies is situated. For example, when we talk about confidentiality, it is very, for example, Corda is very confidential. Fabric is less confidential, while Ethereum is not confidential at all. So figure out the technology stacks that you're going to use, where they are situated. If your use case is in the shaded area and you have a technology X that is here, etc., that technology X can be a technology to be able to implement your use case. Develop a POC. If that POC works, then you can just go on with your MVP, etc. So rather than doing comparisons myself, this is what I suggest, because these technologies are changing during time. Hyperledger Fabrics, for instance, at some point was Byzantine fault tolerant. It is not anymore. And I'm sure that, so Corda is kind of lost. At first they were only for finance, now they are also going into supply chain. They're also hoping that someone would buy them, etc. So these technologies are changing, but my point is that you as a software architect, you need to do these kind of checks for yourself. 2 things that are very important is to understand the consensus mechanism, because it is affecting your scalability and your confidentiality, as well as the architecture itself, because that confidentiality is also a byproduct of your architecture. Like, for instance, as I said, Corda is very confidential, while Ethereum is not at all. Further research questions. So one thing is that this idea of information asymmetry, make it more formalized. That would be an interesting case, that how information asymmetry can affect trustlessness and decentralization. One idea that it was a conference, A.D. Kreis, CEO of Blockshow, he mentioned, that was the only one statement. He says that, what if we use zero-knowledge proof with public blockchains rather than using private blockchains? There was an event that I got the chance to talk with the CEO of Bitfury. Bitfury is one of the most influential companies in the field of blockchains. They are putting the information of Georgia, real estate into blockchain based on the ideas of Hernando de Soto in order to reduce the bureaucracy, etc. And also they are producing ASIC machines. I understood that they had that in mind, but they say that with Monero it is very difficult to reach such a thing. So if you have a public blockchain with zero-knowledge proof, the idea is that you do not have these kind of proprietary solutions like Hashgraph, which is not even open source. You have a public blockchain, put the data there, but because of zero-knowledge proof, you don't know who is the sender, who is the receiver, what has been changed, but all the data is there, and except for you and your partner, no one can read this. So that would be something cool which is not there. Critical success factors for private blockchain adoption, social aspects of blockchains, because right now there is a assassination betting on one of these decentralized systems, so you need to also consider these social aspects of blockchains. And the correct level of regulation is also very important, that we really do not know what kind of regulation we need to have, because if you know, last year China banned all the exchanges to work in China because of some problem that happened. If you remember, in 2017 there was a hacking that they hacked all the that they encrypted all the data, and they were only accepting Bitcoin in order to give you the key in order to decrypt it. After that, China banned everything. So it is very important to come up with the correct level of regulation rather than suffocating the technology. And one suggestion I have is to use the same principles and ideas in system design in other fields, like D3A, which is Decentralized Autonomous Area Agent, the grid system that EWF is developing, based on the same mindset but has nothing to do with software. So using this kind of ideas of replication of decentralization, etc. in other fields. The takeaway for today is just blockchain is a data structure and an infrastructure to save transactional data. There is a shift in political paradigm, in the way that we are working with governments and authorities. We are asking ourselves why someone else should control me, why someone else should see my data. And because blockchain has allowed us to bypass regulations, the best example is Silk Road, the Amazon of drugs, and connecting beyond current borders in order to make a stateless nation. This has leads to a lot of bad use cases. That's why we suggest these 7 properties to choose blockchain over other technologies. The summary is private blockchains cannot be as trustless as decentralized as public blockchains. There are some undeniable benefits of blockchains like this high level of integration, the trustlessness that at this level they have provided, confidentiality, scalability, and throughput are barriers to blockchain adoption, and consensus mechanism and architecture affects these 3 aspects that I have mentioned. Thank you for your attention.
Okay, thank you very much. Yeah, I have a couple of questions. First of all, what is UTXO? That I should ask later. So it's like
yeah. So this is UTXO. So as I said, you have 2 different ways of managing these entities. One of them is account-based and the other one is UTXO, unspent transaction output. In this block, for instance, this is a block and each of them is a block. You have 2 inputs. These 2 inputs are consumed. Each of them is a UTXO. So they can be used, they can be consumed because they are unspent in order to do some transfer to someone else. So you have 2 of them are consumed and a new one is created. You have this output. Now, in another block, I need to send 101 Bitcoin to Jens, for instance. I have this 100 Bitcoin.
It's okay.
So I have this actually, my input, this one is referring to this UTXO. So because it has not been spent yet, I can use it in this block as an input. And but it is only 100, I need to send 101. Therefore, I need to use one of my other wallets as well. So I use another address that I have, which is referring to this other 50 Bitcoin that I have. Again, this is a UTXO because I have not spent it yet. Therefore, it works as an input UTXO. I combine them. Now I have 150 Bitcoin. I pay 101 to Jens, and I make a change address for myself. Now I have 2 new UTXOs. So 2 UTXOs are spent, so they're not unspent anymore. They're already spent, and I am paying 2 other ones. I have created another 2 UTXO. This UTXO is later on has been spent, has been consumed, and another UTXO is created because Jens has paid someone else. So yeah. So this is UTXO.
Okay, so UTXO stands for unspent transaction output.
Yes.
Okay.
And it is not an account, just like for what you have in banks.
Slide 8, please. Yeah, that's about the Merkle trees.
Mm-hmm. I think you can just press 8 and press enter.
Yeah.
Oh, no, it didn't work. It went to 38. Okay. Right. Oh, sorry.
It's not. Yeah.
Okay.
So, when these hash values are computed, are they computed bottom up or top down? What is first, the upper the hash value in the block, or the rest that is below?
You're talking about this one? I mean,
Yeah.
So what is being saved actually in the blockchain? Well, both the structures are there. So you have the transactions. The transactions are hashed, and what is being saved inside the block itself is only the Merkle root. The Merkle root is inside the block. The rest is, I don't know where the rest actually goes, because they changed this data structure at some point.
Yeah, but could it happen that two transactions get the same hash value?
Okay, so
And then
theoretically
you
it
can
is
no longer
possible.
distinguish them.
Yeah, theoretically it is possible, but it is not probable, because you know that it is the idea is that your input can be whatever, so it's a string, so that transaction. So you can also put a book inside the transaction. So your input can be anything, but then the output of the hash value is just a 256 bit. So you are in the space of 2 to the power of 256. So it is very improbable. There are clashes, but it is very improbable that you can find a clash.
So is a blockchain prepared for a clash?
Well, so the idea is that in order to be able to crash this system, I mean all the hash functions they have clashes. So because the idea is that your input space is infinite, but that it is 2 to the power of 256. But the probability of finding such a thing is very low. So I checked the probability. It was by the book of Narayanan for Princeton University. He says that how you can find a hash. It was about 2 to the, I forgot the numbers, but at the end he come up with the idea that it is less probable that in the next 4 seconds Earth would be hit and destroyed by an asteroid. So it was very, very low probability.
Yeah,
because the space is too large.
The question is, what is the reaction if it happens?
Okay, so one thing is that a lot of things can happen to this ecosystem, even, for example, this 51% attack and other stuff.
Would the system at all notice that it has happened? I mean, there could be two identical hash values for different transactions, right?
Yeah.
And so the system will probably say, okay, the two hash values are identical, so they refer to the same transaction, and discard one of them. Is that possible?
True. Yeah.
And from then,
But I mean, what are
from
you?
then on, you have an error in the system.
You have what?
An error.
Not an error, because what would happen is that there are, so for example, it is possible that such a thing happen. One of them would be sacrificed, so it is not an error in that sense. I mean, so you wouldn't get a confirmation. So you have made a transaction, and as you said that it clashes with my transaction, for instance, and because of that you were not lucky enough, so it was not included. Because you don't get your 6th confirmation, you wouldn't give the service, or you wouldn't sell the product at the end. So it is not a serious issue, and the probability is very low because all hash functions have this problem. Just the point is when you find that collision. So MD5, they found collision in that a couple of years ago, but in SHA-3 it has not happened yet. And it's not only SHA-3 because they use 2 different algorithms. They use right MD and
it's not good enough. But the probability is low. I mean, the probability is low that a plane falls from the sky, but it still happens from time to time, right?
Yeah, okay, so here the wording is that the hash functions should have collision resistance properties, so they're cryptographic hash functions, and so it should be computational unfeasible to create these collisions. Once that happens, that hash function is considered broken and should not be used there for that purpose anymore.
I mean, they're all called collision-free, but
Yeah,
theoretically
at
there
one
is a
point
collision.
MD5 was considered collision resistant, and then, well...
But is there a collision detection mechanism?
No.
How to detect the collision? I
It's
mean,
not
you wouldn't
in the-
notice, right? I mean,
No,
you get two different hash values and say, okay, they are identical. One is not needed anymore. And you wouldn't even see that as a collision.
Yeah, so actually you could have different people claiming that Bitcoin was transferred to Jens, and somebody else would say, no, that was transferred to Gottfried, and you wouldn't be able to tell which is really the truth. So that is what we have. So we both could reasonably claim that's our coin, and nobody would be able to tell who the
But one of them at the end would be sacrificed. So the one thing about Bitcoin is that in other public blockchains you have forks. So these forks stay alive for at most 1 hour, but then they would die out because you just discard it at some point. So someone would be sacrificed.
Okay. In my last question is about slide 25.
25.
I was wondering whether there are, for such a situation, there are any formal models, like based on automata, based on Petri nets. I mean, there are states and there are contracts manipulating states, right? So I would think this is a naturally modeled through state-based state machines. Whatever, state-based automata, finite automata, infinite automata, I don't know, Petri nets. Have you come across any such formal model that is used here?
Well, that was one of the ideas for further research, because of using automata and combining it here, that would be a very good idea, but I didn't come across anything myself, because the only place that I read about deterministic execution of smart contracts was in Corda, that they mentioned that. I mean, of course, all the other ones are also doing this, but the way that Corda provides that is how they explained it. So that they say that we have provided this JVM. So I didn't come across anything like that. But that is also a good open area for research from our side.
I could imagine that a smart contract is a collection of interacting automata or something. No? Each participant in the contract is an individual automaton, and they have interfaces like input and output, and then they interact in some way. Surprising that this is.
The problem then is, if these languages are Turing complete, then it gets hard to reason, right?
Yeah, sure. I mean,
the language is
to make it hard to argue, right? I mean, that is one of the goals. To keep it difficult. I mean, nobody's interested in making that easy, right? Because they easily compromise it and stuff. So
but the moment we have Turing complete languages, then everything gets undecidable.
Everything becomes undecidable, of course. But I mean, there might not be a situation where this is relevant.
There might be some hierarchy that you don't need the full expressiveness. But I don't think that's all right.
Yeah. Then this can go a bit about this. Can you have it early by the end of the week? Okay. That were my questions, thank you.
I was wondering about your research questions, I think on some of the earlier slides.
Yeah, I guess it was
did you include all of those questions, or answered you all of those questions?
Yes, but not, of course, I didn't mention everything here. Yeah.
Okay, what were the more larger questions? I mean, usually in the thesis you got one or two more driving questions beside the title. What would that be here? Like finding all the challenges and technology selection, or?
No, actually this is something that came very at the end, you know, it was not really even at the beginning. The properties was the focus, but while I was working on the properties, I understood that everyone was saying that, for example, Fabric was saying that we are trustless.
Yeah.
But then I started working with Composer, I developed a POC for myself, and I understood that it is not really that trustless, especially when I studied the architecture. So then it shifted towards figuring out how trustless a system can be, or how decentralized a system can be. So that was changed. And after doing that, after I look at also into a couple of other technologies like Sawtooth Lake in the thesis or Hashgraph, etc., then I came up with the properties. And at the end, because I look into different technologies, I decided to come up with an approach for technology selection. So that's how it went. So at the beginning it was different. The focus was the properties, but then it changed. Yeah.
I mean, because usually it's easier when you have a set of questions in beforehand. So, I mean, sometimes it's unavoidable that new facts come up, but I think for you it's also easier if you've got one or two driving questions. But when you're at the end of your thesis, you can say, I answered these questions, and you don't need to add more. I mean, it's fine if you answered them all, but it also leads to adding new questions all the time, and at some point you need to stop it to finish, right?
Yeah, that's true. That's true. Yeah, we dropped.
Yeah, that's true. Yeah, sure.
maybe a minor question on slide 22.
Oh, sorry. Interoperability, yeah.
Well, you said that liquid Hyperledger borrow can be used to execute Ethereum smart contracts on Fabric nodes.
Yes.
So what does that mean? Do you have any interaction between the two chains in the end? Or is it just converting one with the logic that you have in the contract to this other chain?
Yeah, but actually I have not done any implementation myself with that, so I've not worked with Burrow, but the point is not about what the data is being saved on the chain, because in Ethereum you can use Serpent or you can use Solidity in order to develop your smart contract. So the idea is that, but Fabric is not an open environment, it is a private ecosystem. So what you save here has nothing to do with what is being saved on Ethereum chain. So it's about the smart contracts that you have developed in Ethereum, you can use it in a private ecosystem on top of Fabric.
Any other questions? This is not the case, then thank you very much.
Thank you.
So no one wants to take chocolate because I'm on diet, I'm not.
Sure.
Yeah, okay, so, maybe you can start from here and...
Can we trust the chocolate? Can we trust it?
Ja, ich habe so was nimmt er denn?
Vielleicht ist ja die lebensmitteltechnische Evaluation der Blockchain abgespannt.
Oh, by the way, I understood that TU München has a course for blockchain now for master thesis. So we're only teaching blockchain. Yeah.
Die Kühlkette eingehalten wurde.